Hi guys, welcome to Science in 5. In this video we're continuing with the discussion on electrochemistry, but we're focusing on oxidation number. To understand the idea of oxidation number, let's use this term bonding power. Okay, so for example, if I had an ion Mg2+, this ion can pull two negative charges. Okay, so its bonding power is 2 because it can pull two negatives. Since it's a positive charge, let's just say it's a +2. In the same way, if I had a negative charge, a nitride ion, this ion could potentially pull 3 positive charges towards itself. So its bonding power is 3, but because it's a negative, we say it's -3. So in discussing this idea of bonding power, we've actually given the oxidation number of these two ions. Okay, so when we're discussing oxidation number, we always tend to look at any compound as being ionic. If we have two elements that are bonded together, we look at them and say, if these two elements were bonded in an ionic manner, which of the two would behave like a cation and thus have a positive oxidation number? Which one would have like an anion and thus have a negative oxidation number? Okay, so that's the first way of looking at it, right? Now, so for example, let's say I have this compound CO2. I know this is a covalent compound, but for the sake of oxidation numbers, we're going to imagine that this compound is ionic. To do that, we need to understand the valency of these two elements. All right, carbon is in group 4, right? Oxygen is in group 6. The valency for carbon will be 4, the valence being the number needed to make 8 electrons like a noble gas. For oxygen, it's just short of 2. The charge that could be formed could be +4 or +2 for group 4. For group 6, it will be -2. Okay. Now, so since there are two oxygens here, we assume that these two oxygens are 2 O2 minus. So this means there's a total of 4 negatives. So the carbon has to balance these 4 negatives by becoming 4+. So in this case, the oxidation number for carbon should be 4, and that of an oxygen is -2. But since there are 2 of them, 2 minus 2 becomes the -4. That's basically the idea of how to do it. Okay, so in simple language, to make oxidation numbers easier, just think of the group of the element that it is in, and then look at the normal charge that it makes when it's bonding in an ionic sense, and then try to figure out which is the more positive, which is the more negative. Okay, now to make this idea of oxidation numbers easier, there are rules that we normally use, okay, so that we can follow through on the idea of oxidation number. Okay, so the first rule says the oxidation number of an element is 0. Why? Because we're saying it's not bonded to anything. So if I have O2, or if I have Cl2, or if I have Mg, then they are all elements, the oxidation number of this is going to be 0 because they are not bonded to anything. Okay, so the oxidation number of an element is 0. That's the first rule. The second rule says the oxidation number of oxygen is always -2, except, the first exception is when oxygen is bonded to fluorine. Now, you'll appreciate that fluorine is the most electronegative element that we have, that we know right now. Okay, so when oxygen is bonded to fluorine, the oxygen will have to behave like it's the cation in this case. For example, look at this compound OF2. We know that oxygen is in group 6, fluorine is in group 7, right? These are the groups. And oxygen, when it's bonded in ionic sense, it's always -2. Fluorine is always -1. But because fluorine now is more electronegative, what will happen is the fluorine will be the one that will be the negative center. Okay? So we'll have to form some kind of equation to figure out the oxidation number of oxygen. So we're going to say let the oxidation number of oxygen be X. Right? Since there are 2 fluorines, these 2 fluorines are going to make these 2 negatives. So, and then there is no charge on this molecule. This becomes 0. So the oxygen is going to have to be +2. Okay, so only when bonded to fluorine, the oxygen number changes. That's one of the rules. So oxygen in all its compounds, you always make it -2, except when bonded to fluorine. But there's also another exception when you've got peroxides. Okay, an example of a peroxide is hydrogen peroxide. Okay, if you look at it this way, the oxidation number here is going to be -1. Okay, the oxidation number of oxygen in peroxide changes to -1. Okay, so when bonded to fluorine, it's +2. Bonded to peroxides, it becomes -1. All right, so that's the second rule. The third rule says oxidation number of hydrogen is always +1 except when bonded to metal hydrides. Okay, when bonded to metal hydrides, the oxidation number of hydrogen becomes -1. Okay, that's another rule there. The fourth rule says the oxidation number of an ion is equal to the charge on the ion. So, for example, if I wanted to get the oxidation number of aluminium, that ion is going to be +3. If I have F minus, the oxidation number is going to be -1. Remember, an ion can also be made up of many different atoms. So, for example, if I have SO4 2-, I already know that the oxidation of oxygen is going to be -2, but how do I get that of sulfur? Make a simple equation. So for the sulfur, we're going to make it X, right? We don't know what it is, but there are 4 oxygens, right? So we know that each oxygen is -2, but there are 4 of them. And we're going to equate that to -2. So in other words, when we add all the oxidation numbers on this ion, they should be equal to the charge. So this gives me X minus 8 is equal to -2. Take the -8 across, you get -2 plus 8 gives you 6. So the oxidation number of sulfur is actually 6. Okay, that's how you would work it out. So the oxidation number of an ion is equal to the charge of the ion. This applies to single ions and also to polyatomic ions. With polyatomic ions, you have to add the oxidation numbers up. Okay, so you add and then you get the oxidation number of the atom that you're interested in. All right. The last rule that we're going to talk about is the oxidation number of a neutral substance is equal to 0. Okay. So if I had a neutral substance like K2CO3, if I add the oxidation numbers of all these atoms, they should be equal to 0. I can determine the oxidation number of, let's say I want to determine the oxidation number of carbon. For potassium and oxygen, it's easy because these are ionic. Generally, when they bond with non-metals, they form ions. So for potassium ion is going to be +1, oxygen is going to be -2. So K is generally +1, oxygen is generally -2. So the one I'm interested in is the carbon. So I'm going to say 1 and multiplied by 2 plus, I don't know what X is, plus the oxygens, there are 3 of them. Each one is -2. That is equal to 0. So now I've got a simple linear equation. Now I've got 2 plus X minus 6 equals to 0. 2 plus X minus 6 is equal to 0. So X must be equal to 6 minus 2, which is 4. So the oxidation number on carbon is going to be +4. Okay guys, that's it about oxidation numbers. Remember, if you do forget the rules, just try quickly to remember that oxidation number is just a way of looking at every compound as ionic. Which of the two would have a positive state in terms of the other? The more electronegative one tends to have the negative, to be like the negative center. That's the one that you assign the negative oxidation number. The one with the lower electronegativity tends to be like the more positive center. That's when you assign the more positive oxidation number. Why we're interested in oxidation numbers is because we can't always see oxidation and reduction using the oil rig. Sometimes we have to use oxidation numbers because we cannot see the electrons changing, but we can follow oxidation numbers. Okay guys, so in the next video we're going to talk about what reducing agents and oxidizing agents are, using the idea of oxidation numbers and what oxidation is. Sharp.